In this video, let's review what our t and b vectors are. The question asks us to look at the curve R and find the unit tangent vector t, find the unit normal vector t, n, and sometimes you are also asked to find vector b. So what are these three famous vectors? Here they are. T is R prime, but if it's unit, you remember you need to divide by the magnitude of R prime. N is differentiate t and divide by the magnitude of the derivative of t. And b is a cross product of t and b. So all three vectors are perpendicular to each other, and they are called t and b vectors. It also was connected to the curvature, which you can see formula in front of you. Here's a nice picture how t and b are connected. Tangent vector is the one that is closest to the curve. It's tangent to the curve, so some translation says it's kissing the curve. Then normal vector is perpendicular to tangent, found like so. And b is found as the cross product of t and b, and if you remember, the cross product gives you a perpendicular vector. Thus, let's start with the first one. T, or unit tangent vector t, is going to be r prime over the size or magnitude of r prime. Solution, let me put it here. Solution. T is vector. A fraction. Derivative is going to be minus 2, because minus 2t. 5 cosine of 2t. In a different video, I think I did this vector already, so I just speed it up. It's going to be minus 10 sine of 2t. Check your chain rule and review the derivative of sines and cosines. And then 5 sine of 2t gives me 10 cosine of 2t. This is r prime. And then the size of r prime will be the size of r prime will be 12 minus 2t squared plus, wait, I made a typo here. First of all, I already can see I'm messing this up. This is supposed to be just 1 prime, and then in the denominator, we're needing to find the size of this vector I just found. So it's actually easier. Minus 2 squared. It's going to be 4. So remember, we're squaring each. Plus, always ignore negative signs, so we're squaring anyways. 100 sine square of 2t plus 100 cosine square of 2t. And now I definitely remember that I did this. I used this vector before in some kind of other video, because you can factor out 100. So minus 2 minus 10 sine of 2t, 10 of cosine of 2t stays like so. And in the denominator, I will factor out 100. And when I factor out 100, I will have sine square plus cosine square, and that gives you 1. So it's going to be 4 plus 100, which is a square root of 104. Does it make sense what I just did? I'll factor it out, and I'll have it like so, as you can see. Sine square plus cosine square gives you 1. You can keep it as the answer, or you can distribute the square root into each component if you want. And then it will be a nice looking vector. I don't want to do that. I'm fine with the way it is right now. So I will put this square root in the black color, and it did not work. So this is the final answer here. Now this was t. N will be, let me change the color. That will be, now differentiate t and find the size of that derivative to find the unit normal vector. So a unit normal vector n of t. b, n of t. I need to find again the derivative of the vector I just found, and then find the magnitude of that vector. That is going to be, so what is derivative of minus 2? 0. Let's point out, before I'm starting differentiating, let's point out something. This whole thing is t, including the square root of 1/4 in the denominator. So maybe it's good if I rewrite it over here. I'll move the picture. And then I'll write down that my t can be written as minus 2 over the square root of 1/4 minus 10 sine of 2t over the square root of 1/4 and 10 of cosine of 2t over the square root of 1/4. This is the vector you need to differentiate. Still gives you 0 as the first component, but the thing is you can choose to factor out the square root and just put it in front of the whole thing, like so. And now differentiate the vector we had before, minus 2, 10 sine of 2t, and then cosine, 10 cosine of 2t. And am I writing the same things too many times? I just wanted to be very clear that what is happening here. So when you differentiate the function, this coefficient is multiplied, the constant multiplied by a function will stay, right? Because derivative of 5t is 5. So derivative of 1 over square root of 1/4 times that vector will be this coefficient in front. We cannot keep it. Now the derivative of the components of the vector, negative 2 gives you 0. 10 times 2 gives you 20. Derivative of sine is cosine of 2t. 10 times 2 is 20, but derivative of cosine is minus sine of 2t, so don't forget to change the sign. And all of this should be divided by the size of the derivative we just found. But remember that you also need to include this, right? So it's going to be a huge square root. And then this piece is factored out, and it will be 1 over a square root 1/4 squared, right? It is factored out. And now I'm squaring each component. 0 squared plus, and I already remember that it's handy to factor out 20 squared. 20 minus 20 will be still 20 squared. When I factor it out, I will have cosine squared of 2t plus sine squared of 2t. Again, it's the same idea we did before several times already. So this is how it looks like. Let's see if it makes sense at the end and matches the answer I have in front of me. So it's going to be a vector 0, 20 cosine of 2t minus 20 sine of 2t. In the numerator, the square root inside of the square kicks out this 1 over the square root of 1/4. So it means they get cancelled out completely. Do you understand that this cancels out with this part? You can write it down for you. It will be 1 over a square root of 1/4. 1/4 divided by 1 over a square root of 1/4, which jumped out from the square root because it was squared, and inside of the square root and multiplied by these brackets. It was factored out, that's why. You can kick it out outside of the square root. And now inside of the brackets will be the number we actually are curious about, because this goes away. So we're going to have this is 1. So it all becomes 20 squared inside of the square root, don't forget. So I would do like so. Inside of the square root, inside of those brackets, 0 plus 20 squared stayed. So after all, it became a vector 0, 20 cosine of 2t minus 20 sine of 2t divided by the magnitude, which is just 20. So actually these get cancelled out. And the vector ends up to be 0 cosine of 2t, comma, minus sine of 2t. And that is my normal vector. That is the answer for the normal vector. And I wanted to say, if we have asked you to plug some kind of value, for example, t equals to 0, then you just do it in each step A and B. So, for example, here you plug 0, you'll get minus 2 over square root of 104, comma 0, comma 10, because sine of 0 is 0 and cosine of 0 is 1. And here, if we have asked you to plug 0, you'll get 0, 1, and minus 1, because cosine of 0 is 1, and minus sine of 0 is 0. The third vector b, which we were now asked to find, is the cross product of t and n. And I don't want to do it because it will take too much time and the video will become way too long. Maybe I will do it in some kind of other video. But these are 3 vectors, t, n, and b. Very important part of the vector calculus to know. Thank you for watching.